Hello everyone. In this video I'm going to go over the solutions for quiz number 4. So initially question 1 goes about solving for a triangle where we're getting different information in each of these scenarios. So we have a right triangle where we have the angle here on the upper corner, and so that means that the adjacent is going to be A, the opposite is going to be B, and our hypotenuse is going to be C. So the first question asks, well, if A is 1.5, C is 2.7, let's find theta. Since we have A, we have the adjacent, and we also have the hypotenuse, so this tells us, well, we should use the relationship with the cosine, since that is what uses adjacent over hypotenuse. So with this, we're going to use 1.5 over 2.7. But because we're trying to find the angle, then we're going to make theta equals cosine to the minus 1 of 1.5 over 2.7. If we plug this in the calculator, this is going to give us 0.98. Now, this is a acute angle, and since we're in a triangle and we're trying to find just a single angle, just an acute angle, then this is fine, and this will be the end of the question. We don't need to find a second angle. Now, for question number 2, or B, we have that A is 6 and B is equal to A. So we have both of the legs of the triangle. So what we can do to find the hypotenuse is just use the right triangle theorem. And so we have C squared is A squared plus B squared. And so that's going to give us that C squared is just 6 squared plus A squared. And so this means C squared is 64 plus 36. Well, backwards. I'm writing this backwards. 6 squared is 36 and A squared is 64. And that is 100. So if you take a square root on both sides, you're going to get from here that C is equals 10. Once that you get that C is equals 10, then you can find theta with whatever relationship you think is best. So if you want to use the sine of theta, you can use opposite over hypotenuse, and so you'll have 8 over 10. And so that will mean that theta will be sine to the minus 1 of A over 10. On the other hand, if you want to use cosine, then you can use it with the adjacent over hypotenuse. So that will be 6 over 10. And then you will have that theta is cosine to the minus 1 of 6 over 10. In any of the two scenarios, you're going to get to the same point. This is going to be 0.93 radians, approximately. Same thing here, it's approximately that. Last but not least, we have the scenario in C, where we're given that B is equals 11, and we have that theta is 1.5 radians. So in this case, we have the adjacent and we have the value of the angle. So we can just use the sine of 1.5. Sorry, B is the opposite, right? B is the opposite here in the triangle. So we can use sine of 1.5 being the opposite, 11, over the hypotenuse that we don't know, which is C. And so with that, C will be 11 over sine of 1.5. And that's just going to be about 11.28. Okay. Now let's go to question number 2. In question number 2, we have an equation. And so we're trying to find out all the possible solutions in the interval 0 to 2 pi. And of course, this is in radians, and we want to express our answer in radians to 2 decimal places. So the first thing that we need to do is, of course, solve for cosine. And we're going to do that by doing 1.5 cosine of x is equals to 4.5 minus 3.7. So if we do that, this difference of 4.5 minus 3.7 is going to give me 0.8. And so we're going to have that cosine of x is 0.8 over 1.5. If we compute how much this is, we're going to get that this is 0.53. Now, at this point, then we can do a couple things. So immediately you could just go ahead and say, well, x is cosine to the -1 of 0.53. And making sure that this is in radians, you're going to get that this is 1.012. Which is fine, but this is just going to give you the information in one angle. So to get the information on the second angle, which you're going to need if you want to have the full score, then you want to use the unit circle. And the unit circle, remember that cosine is representing the x coordinates. So you're looking for a point where this is 0.53. This horizontal line is representing the x. Forget about this being cosine of x. You can think of it as cosine of theta, if you will, if you want to use x in your unit circle, right? So now x is this line, 0.53. And so you have this angle here, which you already got. This is theta 1, right? And you're going to get this one here. But notice that this is in the 4th quadrant, right? And so how do you get an angle if it's in the 4th quadrant? Well, to get theta 2, you need to do 2 pi minus the original theta 1, or the acute angle here that is in the 1st quadrant. So this is just going to be 2 pi minus 1.12, or if you will, this is like minus 1.